Hello, my name is Cameron Pothoven, and my project is looking at the differences between ADHD children and TD children, or typically developing children, and their differences on their phonological short-term memory. So before I get into the nitty-gritty of what analysis I ran, I wanted to give a little bit of information about ADHD children, and it'll help understand the results better. So first, ADHD children tend to have a underdeveloped frontal or prefrontal cortex, which is about 2 to 3 years behind normal children. And what that means is that they've been theorized to have a deficit in their phonological short-term memory. And by phonological, I mean anything that is word-based, so reading or hearing words. And now this is going to be compared to the normal children who are going about 2 to 3 years ahead. Now, this disparity is theorized, but they don't really know what factors go into it. And that's the point of this project. So I wanted to separate out time and their memory load, or how many words they are remembering at a time, to see if there's a difference there. For my test, I used 33 children with 9 total conditions that vary between two words, 4 words, 6 words, and 3 times, 3 seconds, 12 seconds, and 21 seconds for a total of 9. Now, my hypothesis is that since it's theorized to have a phonological short-term memory deficit, I would theorize that there would be an interaction effect between diagnosis and time. What that means is I would expect that TD kids would probably suffer over time as the word list gets longer, the time gets longer, but I would expect ADHD kids to do significantly worse. Now, if that was the case, it would give some evidence to a less developed phonological short-term memory for ADHD children. So first, what I wanted to do is I wanted to just use my data to see if there's any difference at all, just before I do anything. So I ran a one-way ANOVA on every time and every variation of the word list and compared between the diagnosis to see if there's significant difference without doing anything else. And we can see that it's significantly different at every single time and interval. Now, graphed, that looks like this. Now this, I leave here because this doesn't really tell us anything. Other than that, it was theorized that they're already going to do worse. So this is kind of where the theory left off. There, you can see there's a trend that they're doing worse than TD kids, but we don't really know why. This graph doesn't really tell us much else. So from that, I wanted to separate out just the amount of words that they're doing. So what I did is I combined here, I combined every time on those words, and then I combined them into one score. So what it looks like here is that the trend is still the same. So when you combine all the times into the single word list, the trend is still there, which is what I expect because it's the same data. However, even that doesn't tell me very much because it doesn't take into account that there is different time intervals going in. So maybe 21 seconds at 6 words is harder than 21 seconds at 2 words, right? And this doesn't tell me that. So what I did is then I further sparse that out to where I'm going at the 2 words, 4 words, and 6 words. But now I'm separating out into the times, 3 seconds, 12 seconds, and 21 seconds. As we can see here, the trend is consistent. Every time ADHD kids are doing worse than TD kids, and even roughly by the same amount. However, this is where the problem actually comes in. So this is where knowing some theory about ADHD actually comes in very handy. So the theory behind some cognitive research is that in your short-term memory, information that you've obtained doesn't really start to be forgotten. It's for about 3 seconds. That's about how long your short-term memory is. So what I would expect to see at the 3-second interval at every word is that they're about the same score. They should be almost identical, but they're not. And so why is that? Why are they not the same score? They should be. They haven't had time to lose any information yet. And so this made me think that maybe the differences in the score after 3 seconds is possibly because maybe ADHD kids just can't hold the same amount of information as TD kids. That would lead to a disparity in the score. So what I wanted to do next is kind of parse that out. So I wanted to look now at their total phonological short-term memory span size, or their total capacity for word-based information. So how I did this is at the 3-second interval, they shouldn't have lost any information. So I took every child and I looked at the 3-second interval at every word size. And any word size, the highest word size they had 50% or more on, I consider that their maximum phonological span size or their capacity. And with that information, I ran a Pearson correlation to see if there was a correlation here between maybe their span size and their diagnosis. And as you can see here, the correlation was 0.647, that's very high correlation. Even looking at the means here, the TD kids got about 5.3 on this phonological span size, versus ADHD kids got 3.3. And what that means in practice is that kids with ADHD are holding about 2 items less. Their capacity is about 2 items less on average than a normal TD kid, which is very significant. That would explain some of the discrepancies here. So then what I want to know is, does time still play a role? Maybe the only effect is because they have less impressive capacity for their phonological short-term memory. So what I did next is I then took only the scores that every kid had at their span size. So I had these 9 conditions with the 3 different word sizes and the 3 different times. And now I've reduced it down to 3 times, because now I'm only going to look at everyone at their maximum phonological span size. So I get rid of this deficit in their short-term memory. And so that's what this data looks like. So you can see there's only the 3-second, the 12 seconds, and the 21 seconds. Now that's because I've now got rid of everyone's score except at their maximum. So it gets rid of that discrepancy. So now what I did is I ran some comparisons here to see, well, now after I've corrected this, are there differences? Maybe that was all there was this deficit in their short-term memory capacity. As you can see here, at the 3 seconds, it's insignificant, which is horrible. 12 seconds, insignificant. But at 21 seconds, it's still significantly different. So it still tells me that there's something going on here, something that their capacity alone can't explain. So every time I've run an ANOVA so far, it kind of goes deep down into the data to look at individual points. But now I want to take a big picture and really go back to my original hypothesis of looking for interaction. Now I do that by using a 2x3 repeated measures ANOVA. So that takes both diagnosis and the 3 times and compares them all together. So as we can see here, after we run this test, time here has a significant effect. What that means is that time by itself, without anything else involved, is a significant predictor of my data. And then when you combine that with diagnosis and it looks for interaction effect here, it's also incredibly significant. What that means is, while time is affecting ADHD and TD groups, and they're both getting worse, ADHD kids are getting significantly worse compared to the TD kids. But now I want to know, well, maybe that result, it happens at maybe the 3 second, but maybe the result gets less impressive towards the 21 seconds or later on. So I wanted to see maybe the relationship is quadratic instead of linear. And so I ran those models, and we can see here, both time and the interaction with diagnosis are both significantly linear and not significantly quadratic. What that tells me is that the effect of time on the diagnosis, or even time alone, are linear in their relationship, meaning that the change in score over time is fairly consistent when every 9 seconds, which is what 3 to 12 to 21 seconds is. There's a 9-second interval. So next, I've kind of gone down with the big picture here of looking at the interaction. But I want to kind of go back a little simpler. So now I know there's a difference here. And I know the ADHD kids are losing more over time compared to TD kids. But now I kind of want to know, well, how much information are they losing? So now I compared their standard deviation change from their original starting at the 3 seconds. I just saw standard deviation change over time. And now averaged together, we can see that ADHD kids tend to lose about 1 standard deviation of this phonological information every 9 seconds, while TD kids are losing about 1/3 of standard deviation of information over 9 seconds, which is very large discrepancy. So what that looks like in actuality is that every 21 seconds, ADHD kids are losing about 71% of the phonological information they have in their short-term memory, versus a TD kid is losing only about 27%. So to give an example, if I had a garage that is 21 seconds distance away from me, and I had my child here, if he was ADHD and I told him to get 4 items from the garage, by the time he got there, he probably would have forgotten on average about 3 of the 4 items he told me to get. While a TD kid, once he got to the garage, would probably only forgotten about 1. So now let's go back to interpreting all the results together. So what we saw from my analysis is that time affects TD and ADHD children. Time affects them both. The score decreases when you add more time, which is what we expect. It's more effort to keep something in your memory over time. But we saw that there's also an interaction between time and diagnosis using the 2x3 repeated measures ANOVA. What that tells me is that while time affects both groups of children, it affects ADHD kids more than TD kids. Now this is being separated out even more. If we control for the fact that we saw that they had this deficit in their total phonological short-term memory capacity, there is still a difference in their score in respect to time. So why does it matter at all? Why does this report matter? And it's because if I know that children can hold less information in their mind in general, and they're more affected by time regardless of this deficit, if you go into the school curriculums, it's possible you might be able to change the curriculums for ADHD children to include less and maybe over shorter time so they can remember it better. Thank you very much.